Alright, hello all, hello world. I see a lot of y'all have shown up quite early. This is day 78 of studying compilers every day until I land a compiler role. Yeah, I've added a couple more things to the to-do list just so we can, I guess, have a good visual representation of the list of things we need to complete. But this is not meant to be like I guess this is meant to be exhaustive and not necessarily representative of what I work on specifically today. And also, like, further down here, there's a whole pile of other stuff I want to get done eventually, but this stuff is, I think, the top priority. So, yeah, let's, I guess, we can get this started, at least. Yeah, so I think I still need to figure out what I want to do for, like, the fall-throughs, but I think for now we can at least figure out some tree tiling, at least. I have some thoughts about how to do this, at least just from like the stuff from last stream. So let me pull up the damn image from my Discord real quick, so I can scribble on it. Let's get Goofier. Good to see you. Okay, there's our lovely image. So we need to do all the call stuff. The fee I don't think I'm that concerned about. We need to figure out these two. We need to figure out branch and conditional branch. I think branch shouldn't be that bad. I think we just give it a label, and then we can figure out what to do with that label, I guess. How are you, brother? I'm doing alright. Hopefully you're doing alright as well. I'm just really tired from school. I had a midterm today, and then I got the results back, and it turns out astronomy might not be my thing. So, yeah, it's not like career ending, don't get me wrong, but it still sucks a little bit. I feel like I've just gotten worse at taking tests over time. I don't know. Okay, how do we want to do branch? I think, because this is kind of awkward to implement, I guess. I think we could maybe, I guess we could check next node and then, or the next basic block. So I guess like we can do branch and then next branch to next basic block. And if the next one, then we can just no op, I guess. Gone pretty far. Last joined 37th stream. Wow. Yeah, it's been a while actually. Yeah, I think this should just be a no op then, I think, right? If it's the next block, we can just fall through. And then branch, not next, I guess. This one we will just need I guess a branch instruction. Actually this can just be one big node for the fee as well, now that I'm looking at it. Same goes for the call, I think. Yeah, we can do it like that, actually. Or maybe this can be one box, and then the list is kind of a bunch of smaller boxes. It's like this, and then like this gets one big box. We could do something similar with this, but I don't feel like it. I think this is good to leave as a barrier. You can do that. Or we could even just give this one big box. I'm not really sure. I'll figure that out later. This one we definitely want to generate branch. Just a branch instruction. And we can generate labels as we see fit. Can you please explain what you've built till now? Yeah, I guess it doesn't hurt. This is something that I should probably explain. So I guess we can look through the repo a little bit, but the easiest place to look, I think, is just the driver. So we have like a bunch of command line args. None of this really matters too much. The only, I guess, like a lot of this stuff is just like parsing stuff. This is the PAL that I guess is remotely interesting. So the parser, I assume you were around when you saw that. That reads in the source C file, and then it turns that into, I guess, a memory representation that we can, I guess, also turn back into a C file. This is just like the initial memory representation of the program. The main changes I made to it are that this was, I think, like the last 15 or like 15 days probably. We've updated the parser so that we have like real C expressions, like compound expressions, which is this mess here on the right side. And if I open up a test, let's look at the input. I guess op might be straightforward. As you can tell, instead of just having like int c equals a plus b, or like int c then c equals a plus b and then return c, we can just directly have a compound expression here. And it's these sorts of things that the improved parser allows us to do. We also added a lot more operators, which is a decision that I am coming to regret right now, to be honest, because I have to implement all of them now. But yeah, that is what's changed at the parser level. Next, we take that and we do a little bit of processing to, I guess, simplify it down to a little bit more of a basic form. So that is what we call HIR. This just, I guess, gets rid of like the compound expressions and turns them into like individual expressions. It adds, it converts like branch statements, so like if statements, while loops, for loops. We don't have for loops yet, I guess just while loops then. So if statements and while loops, we turn those into, I guess, labels and then branch instructions. So this example is not great. I guess maybe in while, there should be something here, yeah. So we have this label here, and then this is another label. It's like, this goto if is like a conditional branch. And then we also have just straight up goto as well. These are all things that the HIR contains, which allows us to simplify things. It also gets rid of like variable scopes. So it's a little bit less awful to handle that. And then from there, we turn it into our optimizer language. This, I don't remember if you were around for, but it's just a bunch of like, it's pretty close to one-to-one. There's like some other small things here and there, but this is like very assembly-like. And then we've written a couple of optimizations, which is this like passes thing. Some of the optimizations we've had are turning stack variables into actual like virtual registers. So like we got rid of most of the allocates in this memtreg stuff. This is way less complex than the stuff it came from, which is this file. We have inst combine, which does a little bit of constant folding. So like if there's two constants with an operator, it just computes that and then saves that as the value instead. And then we have simplify control flow graph, which gets rid of like some edges and some empty blocks in our control flow graph. It's just like a little bit of cleanup stuff pretty much. There's also like some analyses that these depend on, which have been implemented. And right now I'm working on the backend, so I'm finally starting, I guess, like the stuff that actually generates assembly code. How's this HR made? I made it up pretty much, but it's pretty much like a one-to-one translation. I guess like macro expansion pretty much. Yeah, that's high intermediate representation, I guess, is a reasonable way to describe it. Are you using LLVM under the hood? No. The IR looks a lot like LLVM. I think it might be valid LLVM, but I'm not using LLVM's existing infrastructure. Rather, I am, I guess, trying to re-implement it as much as possible from scratch. But yeah, that's like pretty much a short code walk. Yeah, hopefully that was like somewhat comprehensive, or somewhat useful. And let me know if you have any other questions about anything. Yeah, I guess I can go back to this real quick. I think I can generate labels at the top of each function. So I guess like we could add another box somewhere. Do like, let's put a box here. Like function. A lot more complex. Yeah, it's changed a lot. So here we want to store color or collie reges, and then we want to label, I think. Yeah, this does not fit nicely on one image, I think. This is really annoying. Yeah, this makes sense, I think. Store color, or collie reges, yeah, we need to do that. Or actually no, we could just do this in first block, I guess. Yeah, we should just like write this on the side. So first block will have save reges. Yeah, because we need to figure out calling convention as well, because we will not have explicit functions anymore. What made you dye your hair the first time? What's up, Aiden? It was a rough breakup. And then the funny thing is like so I dyed my hair purple over that summer, and then I came back to school and I was like, yeah, it's annoying to maintain purple. Maybe I'll go natural again. And then I got a haircut and I was like, this looks like this residual blonde shit looks awful. I might as well just go blonde. So I was like full bleached for like a year, I think. And then a year later I was like, purple was kind of nice. I kind of miss it. So then I went purple again, and here I am. I also tried to program my programming language a few months ago. Watching your streams reignites the motivation again. That's good to hear. Yeah, there's a lot of stuff to do, a lot of work, but it's pretty rewarding, I guess. It's really cool to have something that works at the end. Can we get a pink? Maybe. I won't say never, but I will say highly unlikely. We'll have to see what happens. I might end up going back natural, to be honest, because maintaining purple is really annoying. But I also have like a whole thing of purple shampoo, so I think I'll use that up, and then once that's gone, I will I guess, go back to natural probably. How many subs for pink? I'll get back to you on that one. It might be a while. Looks sick, thank you. Best daily nutrition for building compilers? I'm not the expert here. I do not eat enough healthy food, let alone food. What was I looking at? Oh, right, first block. First block, we want to save the registers. I think just every block we want to start with. Or, yeah, basic block. Each one we want, I guess, label. It doesn't hurt to have extra labels, I think. We can figure out a way to coalesce them if necessary. But, I mean, we're not compiling for size, so I don't think that's bad. Let's look this up, actually. Oh, this is fine then. Yeah, I do not care. I will add more labels. I will always add more labels. Yeah, so each basic block will just get a label transplanted on top of it. And I think it will just be the basic block number, to be honest. Is there like a name convention actually? Is there a useful... Can it start with a number? Label names. Oh, okay. So maybe I could just do label and then the number. That's really funny. Huh. Okay, well... I guess function names will still be function names, I think. So I think that's fine. Or I guess we could do local, right? Oh wait, no, that wouldn't work. Oh wait, these numbers are also function local. Okay, maybe we do function name and then just the number as well. Yeah, okay, we could do like dot and then... Yeah, so we can do dot function... How do I represent this? Function and then underscore num, I guess we can do that. Yeah, we can do that. And then at the top of this, we should also have a function name. I guess just function here. Yeah, apologies if this is all very pixelated. 800 by 600 was definitely not the correct resolution size for me to do this with. I mean, just all the basic blocks. I think that's all we need. Yeah, this was a little bit stupid in hindsight. Why do you want to convert the function name? So for the function itself, we can just reuse that, but we have this unit called a basic block, which is, I guess, like a straight line sequence of instructions, and we need to convert those as well. So it would just be, when we don't have like names for the basic blocks, they just exist. And that creates a problem because we need to give it a name. So I have this function that, I guess, gives each basic block and each register a number. So I'm thinking I can just reuse those numbers and then turn those into labels. I'm concerned about how it would handle, I guess like labels are all global is the other problem. So I can't just like reuse like the number 1, because then if I have like 3 functions, each of them will have a label number 1, and that will cause a problem. So my plan for that is that I will, what's it called? Yeah, I will, I guess, add the function name to it so that then it becomes unique. So instead of having like 1 and then 1 and then 1, I will have like function 1 underscore 1, function 2 underscore 1. And then like if the third one's named like foo, it'd be like foo underscore 1, for instance. And that will solve the uniqueness issue, I guess. Yeah, so this is all like block level. So I guess I can separate this out. These branch instruction ones make sense, I think. This is an R, by the way. I think. Yeah, so let's get rid of this box. Oh, that's not what I wanted. Let's fill that in. Is this all that? Okay, yeah. Let's just merge all these down and then we can do the cleanup work real quick. Yeah, we're gonna, this is a little bit scuffed, but don't worry about it too much. Yeah, so this I am less concerned about than everything else. The one that I am concerned about is the conditional branch, because we kind of have this situation, but there's like 3 different cases. I guess depending on the next block. So we're just like, I'm just gonna write this out instead of like making an explicit tree for this, I guess. Yeah, this node will just be like, this will be a special type of node, which is just like list of function, I guess, which is really funny. Yeah, or like list of instruction rather. So like if you've written just like straight up assembly in like C code before, it's like kind of doing the same thing, which is kind of funny. I could probably do the same for all of these special cases down here actually. The more I look at it, it looks like that would make the most sense, because I need to do that for like call anyway. That would be smart, yeah. Holy hell. I should do that. Okay, I think that's what I will try to do. I think that also gets rid of like a certain node type that we have to add, which was like causing me a lot of headache, because it felt really silly to add like a call node that only handles call, or like there's just like a lot of different things. This might block some optimizations, but yeah, we'll I guess fix that later. If anyone that has like done instruction selection before has any thoughts on that design choice, let me know, I guess. Compiler would for a certain system. Yeah, I'm trying to generate x86 64 specifically, so I think I'm generating pretty platform agnostic code in that regard. But it's hard to say at a glance, at least. My target state is like just an elf assembly file, I guess. And then we can just like stick it into a linker, an assembler, and then run a binary. And that will be a good time. Yeah, I think once we get all the way down to like something that is real assembly, I think we'll cheat a little bit. And instead of writing a linker by hand, which is like a whole nother can of worms, we're just gonna call the system linker and call it a day. Actually, let me look up how to do that. Oh yeah, we can std system. That's really funny. Yeah, and then we can like, yeah, we can like have a switch based on the OS. Have you tried Cursor AI before? I haven't, but I know of a couple of people that have. It seems very strong. I don't particularly feel like using it, so yeah, I write code to learn, not to be fast, at least. Cond branch. Yeah, cond branch, we want if descendant or successor, I guess. Not next. Gen a, or we want to generate a compare, and then compare, and then we want to. Yeah, this is illegible. My fault. So that's a G. That's an E, I promise. That's an N, I promise. If you had no join programming in the first place, what does it matter? That's true, but I mean, the fact that I'm streaming shows that I at least have some joy in programming. I used like GitHub Copilot for a while, and like over the past 2 years, and I think as I've learned more about coding and I guess matured as a programmer, I feel like it's become less and less useful to me. And it's also just like not really the workflow that I enjoy. Because like you like type a little bit of code and then you see what it vomits out, and if it's not what you want, then like you type another space or something and then like it vomits out different code and it's like bruh. It just doesn't really feel great to me, at least. Like the fun part about writing code is like actually writing the code. Like nobody enjoys reviewing code. Like I don't think I've met a single person who is like, yeah, my favorite part about programming is just like reading over code that other people wrote. And it's like it just feels very dry, and like if I had something else like write the code, then like it's just like what's the point for me, at least. I'm not one odd person, fair enough. Like 9 out of 10 dentists. There will be that one dentist, like, yeah. So we want to spent the compare or compare with or compare not 0, and then if it's not the next one, then we want to gen a cond branch. Successor 1. Yeah, we can do this, I guess. Too much clutter? I mean, that is a valid reason. It's all user preference at the end of the day. It's all like, at the end of the day, you can use whatever tooling you want. A lot of people use Cursor because they just want to make things work, and that's a pretty valid reason. Like, if you don't really care about the process and you only care about the end results, I think AI-driven tools are very useful. Or at least like agentic AI for these sorts of purposes, at least. I wouldn't think of it as like a too smart or like not smart enough sort of deal. I think it's just like, is the workflow something that you want? And do you think it's actually helpful? And if the answer to both of those is no, then I don't see a point in using it. But if the answer to either of those is yes, then by all means, feel free to use it and make your own decisions. Like, a code editor is a code editor at the end of the day. There's still gonna be someone designing code, I think. Okay, this seems like a pretty stable place to look at the trees. Yeah, let's do something with this now. So let's go to MIR to LIR. So we have register, immediate upload, store, and return. I think we should get rid of the return node again, and then we should do the thing. the thing. I think the return node we should actually also redesign to, I guess, be straight assembly, because that's also kind of a barrier thing. Yes, we can do class. We can just do like LIR node. This is really silly. Yeah, so let's do this instead. And again, if anyone has done instruction selection before in their own compiler project, let me know if this is even a good idea. I think it's a good idea. I could be completely wrong. Yeah, please let me know. Also, how do we generate fees? I think we still need like a literal fee node of some sort. That can't really be propagated into like an instruction, at least, I feel like. The reason I'm that one odd person is I like to do malware analysis in a VM. I guess that makes sense, but like, I don't know. I guess like, I feel like that's a completely different use case though, rather than like using it to generate code. And correct me if I'm wrong on that. Okay, so how do we do this? I guess we want a stud unique putter or stud list of LR instruction putter. No, this would be unique putter. Yeah, let's make unique putters. And this will be assembly. Yeah, we can do that. And then yeah, we can do that, I guess. Referring to reading code rather than writing, that makes sense, yeah. I think it's very useful to explain code at least, or like explain concepts. That's what I've been doing with like ChatGPT sometimes when I'm like confused about a concept. Eye doctor? Damn. Well, take care, man. Thanks for showing up to the stream and have a good one. Why do I have the urge to learn everything? What's up? Yeah, I mean that's not a bad thing. Like, I have a couple friends that just very much want to learn a lot of things and are just limited by their time and energy. But yeah, I think that's a pretty good thing. That means you're a very curious individual. I've been doing all right. Hopefully you're doing all right as well. Okay, we can do this, and then we can do. Is this compiler multi-threaded? Not yet. That's something I want to think about in the future. I think I could run different analyses in parallel. That might be something interesting to think about. Right? Would that work? Yeah, because all of the memory is read-only, I think. Or like we would be treating it as just reads, I think. Or at least the CFG. I don't know. I'll have to think about how I would multi-thread a compiler even. It's something I haven't given a lot of thought to historically. Okay, we need a constructor, I think. Do we need a constructor? Yeah, we need a constructor. Yeah, so we can lir node list of stud unique putter of lir instruction, and this will be assembly. Yeah, okay. So then we can also get rid of the return node stuff, which was a little bit strange to begin with, I think. Are you using Vim? I'm using NeoVim rather. Have you read any books regarding compilers or building them? I'm referencing a couple of books. There's the Cooper book that I've been looking at. I think that one's pretty commonly referred to. There's the Muchnick book, which is more about like middle and like optimization stuff. And then there's the Rastello SSA compiler design book, which is what I'm referencing for SSA related stuff. So static single assignment, which I kind of don't want to explain right now. So if you're curious, then like feel free to look it up. I think the Wikipedia page is pretty good on it. Okay, so we can do this. We don't want to do this anymore. We want to just generate instructions, I think. Are those physical or digital books? They're technically physical books. They're like giant textbooks. I have digital copies of them that I've attained through completely legal means, and you should definitely not look on shadow libraries of any sort online. Okay, so we want to do calling convention somewhere here. or pop, or What does the return need to do? I guess we just do calling convention stuff here. Just a ret? Will we possibly put the names of these books in the chat? Yeah, I could just like Cooper compiler, engineering compiler. Yeah, so this is one of them. You can look this up. You can pause the VOD at any point. Ignore what's in my cart. Yeah, that's one of them. This is another one. Advanced compiler design and implementation. And then the third one is Rastello SSA-based compiler design. These are the big three that I've been referencing for the most part. If you're like trying to start from scratch, I would recommend none of these. They're all very dense and they're more reference material than anything. I would recommend crafting interpreters as a start, rather, if you are trying to write I guess like work on a compiler from scratch or like follow a tutorial somewhere. This is probably the best place to start. There's an ebook, it's completely free. Or a webbook, rather. Let's go 360 sauce. Good to see ya. Streams have been on my free page for weeks now. Very awesome stuff. Thank you. Good to see my content is making it out to more people, I guess. Half a crafting interpreter is good. That's pretty good progress, I'd say. Explain multiprocessing in terms of the OS. It's like when you are multitasking IRL and you have like, you have to worry about like doing the dishes and doing laundry and then doing homework, but you need to figure out the optimal order to do those. And sometimes that involves interweaving them. And depending on what your criteria for doing them well is, you will have different priorities on how to do them. You can do a little bit of all of them at the same time to make it seem like you're making progress on all of them in parallel, or you could do like one at a time completely, for instance. And there's a lot of other more complex ways to do it, but sometimes you can literally do two things at once. Other times you will have to pretend you're doing two things at once, I guess. I'll get back in 10-15 minutes. No worries. Take your time. The stream will still be here, I guess. Good luck with your work. Thank you. Okay, this should be LIR node. Or LIR node. Let's just make it caps. That seems reasonable enough. Yeah, we can do that. We can do that. Okay. So we want a list. Then we can do that. And then so move assembly. Okay. So we have a ret instruction, right? I hope we do. I'd be upset if we didn't. Okay, we have a ret. That's good. Brown IC6 cheat sheet. I will keep referring to this for a while. Okay, so we want to save registers. Yeah, so we want moves to restore those. We want to restore stack and base pointer. Yeah, that's what we want to do. So we want to restore poly saved registers. So that's the to do. We want to reset stack pointer and then I see. So we want to pop the base pointer, and then we want to generate return just the ret. Yeah, so that's what we need. For now, I think we can get away with this, and we can generate the assembly later. For now, I want to scaffold all this out. Function params, god damn it. This will always haunt me. Is this fine? I think this is fine. Why is this a question? What do you mean, what do? We just save that, I think, right? I don't know anymore. What am I doing? I think that's fine. Do that. Yeah, we can do that, and then yeah, the rest of this we will have to. We can just throw more to-dos on this. I think this will help the program take shape at least. But this will be at least a good start. I'm very good at over-scoping myself, historically. And it happens a lot. Okay, just checking Discord, apologies. Okay, so then we can do fee real quick. I think this we will have to make a node for, unfortunately, which is kind of funny. The reason for that is we kind of need a special case. It wouldn't really generate assembly, but it's just like information for the register allocator once we get to that point. So I think we need a special node for that. Okay. So that will come here, I guess, or not in there at all. It'd just be in the header. So LR node's kind of ambiguous. Should just be like ASM node. Yeah, so we can do fee node, public node. So we do that for a second. Did I rename in here as well? Or ASM. Yeah, we do ASM here. I'm competition, but my girl don't let me study. Shall I leave her? That's a decision for you to make. I can't give you a decision on that, but it's up to you to figure out what you value more. Okay, so we have that. I think this is all the nodes we need, which is very good news, because then we can merge things easier. I think this is fine. Okay, I think we can steal all of this. We can change this to like do that. That, I guess? Oh, I lied. That doesn't work. That doesn't let me do that. Because ASM is a keyword. We can make this like instructions. Instructions. Yeah, okay. Do compilers always need HIR, MIR, and LIR, or is it an optimization thing? So I guess like it's, I guess these three are all things I've kind of made up at least. I've created these as such so that it is easier to, I guess, divide responsibilities between the three, but I guess like they aren't like strictly necessary. It is very much possible to just go from source code straight down to like some sort of another language. Like for instance, like a really simple compiler, just like if you wanted, for instance, if you have like a program that like has the word return substituted out for like ret, for instance, a compiler for that quote unquote language could literally just go through and find and replace all instances of ret and replace it with like return. That's like an example. But depending on what you want to do, it might help to make different IRs. And you can think of it as like setting up a sort of pipeline almost. And that's all just like a big design choice. I like having different IRs for different purposes, depending on their structure, but it's all I guess up to your preference at the end of the day and what you think makes the most sense for your goals in the compiler. So like for instance, all of this stuff here, this IR is designed to be as close to the, I guess like a memory representation of the assembly as possible. So that's what LIR is supposed to be. HIR is supposed to be like a simplified version of the C language. And then the optimizer IR is like a control flow graph so that we can, I guess, analyze the flow of data in the data and instructions, I guess. Or data and execution, rather. As a C programming, it's C++. Welcome back, River. Okay. So yeah, I guess I will copy this boilerplate down to all of these at least, which is nice. Okay. We need to change the to-dos in here, obviously. So the branch is straightforward, I guess. Generate branch instruction if next block is oh, I guess TreeGen visitor needs to hold more blocks, huh? Or it needs to, we need to like hold current block and like next block or something like that. Yeah, so if next block is, or if branching to next, or we generate the instruction if the next block is not the same as the one. How do I put this in English? This English language thing is really hard. Generate branch instruction if, I guess, if not branching to next block. We can label that as that. Press Denoise T, do some stuff, generate assembly. Yeah, that is like an example. And there's like a lot of architecture in modern compiler design that is just like necessary for like maintainability reasons. And there's like a whole spiel I could give on that, but I've given that somewhat recently, so I don't really feel like yapping about all that again. How do I change this? If neither instruction is next, generate conj branch and branch. If one is next, generate conj branch for the other. Yeah, okay, that seems like a good. Let's just make this branch as well like that, so it's shorter. Yeah, okay, this seems reasonable. What am I doing here? I think I should probably also have a thing to, I guess, generate label for basic block, maybe? Or some sort of, something to make that less awful. Yeah. Yeah, because I don't want to implement that right now. Let's add the header stuff real quick. I think we just define, oh, I need to define this properly. I guess, we could make nodes for sources, I guess. I don't know how to represent a fee properly here. I don't want to do node putters. That sounds awful. Yeah. It would have to be register node or immediate node, I think. And I think in that case, we should probably just like make this a node, and then we can do like the resolve value thing that's here as well. Yeah, so I guess we could make it take nodes at the end of the day. For better or for worse. So we can do stood unordered map from, I'm sure this will not bite me in the future. We don't need an unordered map. We can just do a list, I think, because they are distinct values. I think. I feel like we'll be calling it a day at some time. I probably got another hour in me. I'm not sure. We'll have to see what a good stopping point looks like. But yeah, I've been like looking into better ways to like do all the stuff off stream, because I think it's relatively uninteresting to just watch me sit here and be like, how do I do this? And then like maybe like skim 2 papers and be like, this is not helpful. So I've been trying to do more of that off stream, but sometimes there will inevitably be some streams where I just like read things. Like the last couple of streams I think have been a very good example of that. And they've all started with like some progress, and then it stalls very quickly. So yeah, it is what it is. Okay, so we want a public and then private. I think we just need a constructor to set these. Maybe not. The way I'm doing this is like really irritating me actually the more I think about it. I should just pass everything in at once. It's not like we're gonna be... Oh, we are gonna be updating it. Okay, maybe all of a sudden this doesn't suck so much. But the assembly node I don't think we're gonna be updating. We might be like returning the thing so we can actually like extract the assembly from it, but that's completely different. I think we have a tile for assembly, which is just return the assembly, which I think is, it's a really funny implementation. I think this is reasonable. I don't know, Harold, what do you think? I feel like you'd be able to give the best advice on this. And if anyone else has an opinion on this, like, please let me know. Just like, instead of having like specific nodes for like, I guess the different terminators, we just have a, we have a node that is just straight assembly. This will also help with like function preamble stuff as well. This will handle the terminators and then calls specifically. And I guess in the meantime, I will fill in the fee node. This will take constructor. I don't know how that works out. Okay, I mean, fair enough. I'm thinking the end result is just like a list of nodes. We only count these ones in terms of like uses for merging trees, and then for tiling trees, we just I guess like these won't get merged into anything else, so they are inherently just atomic nodes, and then like I guess the assembly it generates is just the assembly it stores. And I guess that's just like, you can kind of think of them as like barriers in a sense. Yeah, I guess if anyone has any like reason why this just straight up would not work, please let me know in the chat. Is this compiler a hobby project? Yes. I am completely doing this of my own volition, not for a class at all whatsoever. Okay, so the constructor for this I think will take a std unique. Let's just copy things. Can I paste it? No, okay. Let's copy that. Let's paste that in here. This will be this will be like destination, and then we can do like std list of std unique footer to node and source. I guess we can do that maybe. I guess like 2 and then from. Yeah, I think this will be the constructor, and we can extract these from this. Yeah, like that. So that's the fee node. I'm gonna commit in a bit, but I want to finish this stuff up first. So return branch con branch. I also need to implement call, which is I guess the opposite of a return. Kind of interesting to think about. Yeah, we can do this, I guess. So we want, I have this in my little pile here. Does this all look reasonable? Yeah, we've handled these already. We're handling this call stuff right now. I wanna put this on a separate screen. If you want to like keep this box up, feel free to like take a screenshot of the stream real quick. I hope it's not that blurry. Oh yeah, just like take a screenshot. I'll give this like 10 seconds. Okay, I like. Hey, you can rewind the stream if you really care. Yeah, okay. So let's get rid of these. We want to push ret label. Oh, I see. Are you making it for learning or want other people to adopt it? This is mostly just for learning. I feel like if anyone wants to use the compiler toolchain, they should definitely just use LLVM. But also, like, if someone were to, I guess like LLVM, I guess popped up as like a research project, so there's always a chance that this becomes something. But I'm not making it with the intent of that, at least. Okay, so we want to push caller saved regis. Or caller saved registers. Oh wow, I can't type. So do that. Move. Or it's like move params into registers. We want call. Wait, what? Call ret label. What was I doing? Wait, what? What was I cooking? Stack is philo. Yeah, okay. I've never seen anyone say philo. I've always heard LIFO. FIFO and LIFO. I've never heard philo before. That is crazy. Okay, calling a function. So we want to call the function label. And then we want to ret label. Okay. Okay, that's what we need, I think, that whole pile. Do we need to restore registers? I think we do need to restore registers. Right, or this comes here. Yeah, okay. Yeah, okay, that makes sense. It's a good stream, all the best. We'll join back tomorrow. Well, yeah, thank you for showing up to the stream and have a good one. I tried searching what a phi node does, but I do need a special node. I guess the point of a phi node is that it all goes back to SSA form. So I guess I can give a short explanation on that. It's been a while. Call pushes the return address. I guess that makes sense. Let me look at this. Oh. Wait, that's quite nice actually. Okay, I guess I was thinking about making a ret label, but I guess we don't need that then? I guess I'll add a question mark here. I need to think about this more. Calling convention is hard. Yeah, don't worry about derailing it. X64 compiler, yeah, pretty much. That's where I am. So yeah, SSA form. Actually, I have tests that I can use instead of drawing things out. Okay, so we can go to test. Let's question input memtrudge. Okay, actually, let me just open it here. Actually, yeah, this will be the easiest way to show this, I think. So the memtrudge here. Here's a couple of tests. These sorts of, I guess I'll pull this up alongside the memtrudge output. Yeah, okay. So ignore this fun call thing at the top. This is just a function that I have here for some reason. I don't need this anymore, actually. I used to have it for a reason, but yeah. So I guess this mem to reg basic example is a pretty good example of what SSA does. So without static single assignment, so let me back up a second. Static single assignment, it is the idea that you assign each variable once, and that's useful because that makes code analysis a lot easier and a lot less expensive to perform. So I guess in this example code here, let me just resplit this properly in the slowest way known to humankind. Yeah, so in this code here, we assign 0 to A, then we overwrite it with 5, and then we assign B to whatever's in A, and then we return B. So then, I guess, just from like a human perspective, it's pretty trivial to figure out that what B ends up as is 5. But from the program perspective, it's a little bit awkward because when we're doing like code analysis, these two both are quote unquote A, and that makes a really big problem because then we need to figure out like which one is currently alive. So then like the traditional way to do this is with like liveness analysis, I think is the term. You have to like figure out at each instruction which variables are, I guess like, which values are active, I guess. And that is just like a complete mess. So the way static single assignment gets around this is it basically says A0, or like A0 is 0, and then instead of reassigning to that, we set, we create a new A, and we call this like A1 for instance, and we assign that to 5. And then what this ends up turning into, this B assignment, it becomes like B0 equals A1. And then from there, it becomes almost trivial to figure out which value of A is being used, because we've specified it comes from B1. So we know this one is B1, so it's 5. Yeah, but then, so that seems like all fine and dandy. But then we have an example like this, where we have a branch statement, we have an, I guess, we have an if here that assigns y, an else that assigns y, and then we're returning y. So the question is, what is y at the end of the day? And if let's try to apply the previous SSA stuff we had. So here, so we can like evaluate this thing, that would get something, but that's irrelevant. So here we assign y0 to 1, and here we assign y1 to x plus 2, and then we return y0 or y1. That, and this is, I guess, where the problem arises. We don't know which value of y to use because both of them can potentially be valid at this point in the program. So what we end up doing is, if you look over here in the generated assembly, we insert this phi function, which is basically like if control flow comes from the if block, then the value will be 1. And then if it comes from the else block, then it's equivalent to x plus 2. So it doesn't really exist as a quote unquote instruction, but it's more like a, I guess the reason it's called a phi is like it was literally coined a phony function, or a phony instruction, and it sort of is like, I guess, resolving which use exists at this point based on the previous branch. But yeah, that is the long explanation with all of the build-up. The reason we need a phi node is because the most recently saved value doesn't really exist, because we can't quote unquote save values in SSA form. Yeah, let me know if you have any questions about that. I think I went over that at a reasonable pace, but there's a chance that I went a little bit quick over something. And A0, A1 are separate nodes? Correct, yes. They both figure, or I guess like, from like a literal program perspective, they refer to the same variable, but from a code analysis perspective, you can kind of understand them as separate variables. A variable can have multiple, I guess, like, sub-definitions. Just like each definition is treated as a new variable, pretty much. Yeah. Do you ever feel like or fear that you'll need a break from this? Honestly, I think I've been enjoying this enough to the point where I don't think it's gonna be very easy for me to get burnt out. At least for me, this is just very, very enjoyable code to write. So, in that sense, I think it's very unlikely I get burnt out, but if I get to that point, I will definitely take care of myself. Okay, I think that's everything, at least scaffolded out here. We need to like actually implement these to-dos, but that I think I really don't want to do right now, and I'm kind of lazy. So we could also just not do that. Oh, what's good, Janine? Good to see you. How are you doing? We don't need this thing. Yeah, we can... This is fine. Need to implement that. Is it a crime that I wasn't exposed to compiler internals? Not really. I mean, it's a pretty niche topic, and it's not everyone's cup of tea, so I don't blame you for that one. Okay, how are you? I'm doing alright too. It's good to hear. Okay, we have resolve value, and then we want a new thing here. I guess like we want start or generate label, and this will take middle and MIR basic block putter. And this will be, this needs a name. Okay. This was busy teaching HTML full stack. That's fair, yeah. That seems like the most applicable, at least from an industry perspective. The more I think about it, the more I realize, like, computer science really should be more theoretical. Like, it's called computer science for a reason, not software engineering, I guess. Like, all the other engineering majors have their own engineering thing. Even computer engineering, I guess, exists, but that is completely distinct from software engineering. Like, we have Chemi, we have BME, we have IE for some reason, industrial. Surely, if we wanted this to be, like, proper engineering, we would do software engineering. But that's completely different, at least. Okay, so we want visitor, monads combinators. Yeah, I'm gonna be honest. I can't understand what a monad is. I've tried staring for like half an hour and it just didn't make sense. So I figured the next half hour would not give me much value. I'm gonna take more of a look at it in the future, but it's all theoretical. It's all functional slush. I think if I were to do more stuff with functional languages, it would be important for me to know, but as of right now, I don't think it matters too much. We do start BB here, I think. Or start basic block, I don't know. That's what we'll call it. Okay, so we need start a basic block. We want, or maybe we could just like, yeah, this is fine actually. I think we could even make a, actually no, we have to do this because there's no other way to, I guess, access the internals yet. So start basic block, we want start function, I guess. And then we want like close function, I think. Yeah, we definitely need to close function, I think. I'm going to close function or end function. Oh, that's start basic block. I think that's fine. Or these should just be void. Yeah, we can do this, I think. And then it should take middle and MIR. It should take function putter. Yeah, let's just paste over this. Do end function like that. That seems pretty reasonable. What's wrong here? Big F. Okay. What else do I need? We need to update the contexts thing. I guess we could do like, each context will be a, No, this doesn't make sense. I guess like, I don't like the word context here, I guess. Cur function? Or I guess like, yeah, cur function. We can do like a list of these. This is per function, so this would be all functions, I guess. Or it's like, oh wait, we could do function nodes and then program nodes, I guess. We can organize it like that. And that's fine, I think. Yeah, because each function will just have a linearized set of basic blocks that get turned into nodes. And that goes across basic block boundaries, so that should be fine. I really enjoy my studies as well, but I've been doing nothing but that just for hours and eventually ran out of fuel. That's fair. I mean, if you are just like bonking your head against the wall, that will, I guess that kind of just is how it is. It's also like very difficult to rest nowadays, I think, just in modern society. So like, make sure you take your time and like, I guess, spend your time doing something fulfilling that recharges you and I guess sharpens your blade. At which university I'm going to be going to, how to compile this course. Yeah, I feel like unless your professor gets into like very software engineering-y bits of compiler stuff, it's a better use of time to just self-study it. Yeah, crafting interpreters is just great. I cannot recommend it enough. So that would be, I guess, the best place to self-study that if you're interested in it. And again, like, this does not mean you should rush into it. By all means, take the break if you need to, because it's not wasted time. You are, I guess, like, making time, if that makes sense. You can think of it as like making capacity for yourself to do more strenuous work. I think that's the healthy approach to it, at least. Okay, so here each function, so we want to linearize it, and then visitor start function, and this takes f, I think, f.get. Yeah, we can do that. So for each basic block, visitor start basic block, and this takes basic block putter. What's good, Skills? I only see your YouTube tag now because YouTube is stupid, so I see blueberries. Yeah, I'm doing well. School is difficult. I got bonked over the head by astronomy, but you know, we get to write code, so I'm happy at the end of the day. Hopefully you're doing alright as well. Do you keep up with date with the recent Valorant tournament? Yeah, it's good to see NV1. I'm quite happy that Exter is in tier 1. He quite deserves it, I think. He's just been pretty low-key on everyone's radar, and it just feels good to see him finally hitting his stride. Okay, so we do this per basic block, which is fine, and then we can We can do the same thing here with end function. I don't know if there's anything. Oh yeah, we need to just push, I guess, onto this. Yeah, this makes sense. I think this is fair. I think this is all we need per function, and then yeah, then we just have a list here. So then yeah, so then we can void get result. This should actually just be the type at the bottom here. Yeah, if we just paste over. Okay, perfect. That works as we wish. So then we can do I guess we can do trees. I guess program trees equals, yeah, actually we should just call these trees. So then we can do get result from, or yeah, we can do visitor get result. Okay, so that gets all the trees, and then merge trees we want to like, for auto function trees in program trees. Yeah, let's just throw this in here instead. Yeah, we need to figure out an algorithm for that still. And then tiling. Yeah, and then from here we need to figure it out, but I think that's a reasonable start for this. I think we could just pass this by ref, actually. Or we have to anyway, I think. Yeah. Gotta log off. Thanks for explaining things, of course. Thank you for showing up to the stream, and have a good one. Okay, so then we have... Huh. Yeah, we should only merge per function, I think, so this is fine. Oh, wait, no, this makes a mess. Oh, fuck. Okay. I don't know. I'll figure that out once I get there. And then we should just have a... We should still have a list of tree, I think. I guess we have, like, stood. What is this? It's just a list? In the LIR proper? Yeah, we have a list of stood, unique, footer, LIR instruction. This is... I guess... instructions, I guess we can call it, or auto, Yeah, and then from here we can just go through this and just tile the trees, I think. I think it's fine to leave this in place at least, the structure. And then like for auto tree in function trees can we can do it like this, I guess. Yeah, we can do that. And then final cleanup, we have instructions, so then we can finally we can do auto, or I guess like LR program. Yeah, this should be LR equals, or yeah, we can do this, and this takes in stood, move, instructions. Yeah, we can do that, and then return, stood, move, LR. Yeah, okay. So what's wrong now? Current context, oh. This should be, let's rename this. There's no symbol? Are you kidding me? Okay, we're gonna do this the cringe way. What's your Valorant rank? I've peaked Ascendant 1. I'm currently Diamond 2. I'm a little bit washed. I don't left click the way I used to anymore. At that point in the semester when large assignments in multiple classes are all due in the same week, yeah, it's always Doom week, but as long as you, at least for me, I found that blocking my time out well helped me get through all of it very succinctly. I won't say easily, because it was always very difficult, but it was always doable, at least. Yeah, so we can do, yeah, do that. Okay, so all of this has no errors now, I think. No errors, no warnings. How many to-dos do we have? 18. God damn it. And that's not even counting the stuff we haven't implemented. Yeah, okay, that reminder's for me there. I guess we could implement the rest of the visitor stuff, because I forgot to do all that. As in, I haven't had a second to do all that yet. So we should do a get result real quick. This should be pretty easy. Yeah, this should be tree-gen visitor. This should be turn, stood, move, program trees. Okay, perfect. And then we could probably clear it, but I don't think that matters, so at least we're not reusing it or anything. Okay. So then resolve value. Alright, no. We should do start function, end function, and start basic block next. Let's make a quick macro real quick. So record macro, go to start, word here, tree, gen, visitor, double colon, end, curly braces, next line. So now we can replay that. And there we go. Okay, this, I think, oh god. We might have to do the assembly node stuff again. This is so scuffed. Yeah, so we need an assembly node here, I think. So we want to generate the function label. And then do callee. Okay, so we need to push callee saved registers so we can steal this line actually. Yeah, so we can do that. I'm trying to think about how we can even allocate space properly, or at least grow the stack frame. I think we just count. We might just have to do counting, which is really funny. Okay. Writing a function. Local variables. I guess we could run this optimization once later. at the end here, I think. I don't know. We could do like one pass over it at some point. We need to figure that out though. Okay. End node, I don't think we need to push anything here. We need to generate the label. I don't think we need to give it the function putter. So I'm gonna get rid of that. So program trees push back. Stud move function trees. What if I do this without the stud move? Will this yell at me? Okay, well it doesn't look like it's mad at me. Fill in the prologue after regalloc? Oh yeah, you're so right actually. But then, how do I keep track of where the functions are then? Yeah, this is tough. Wow. Okay, let me fix this signature first. Okay, this doesn't yell at me for some reason. Yeah, I guess where would I keep track of it then? Where am I? Oh, here. Should I just move then? I think I should move. And then... I think that's fine. This looks like valid code. Here we should generate label. Yeah, well, I think this is a reasonable list of things to do. Assembly is hard. Holy hell. I've not thought about assembly in way too long. Yeah, I guess maybe I should just... I guess I should probably save that somehow. Then how do I encode that? Good luck today, thank you. Yeah, I like assembly too. I just forgot how it works, which does that make me a fake fan? I'm not sure, but maybe it does, maybe it doesn't. Oh, I need to generate feed, I forgot. We have this feed node thing. Or we should stud make unique fee type. So this takes, we want header2 value of I. Or we want LR get, or not LR, NIR. This is number IR. So I'm gonna get number from I. or I. What does this take? Yeah, it takes a footer. Why isn't this working? You went 64. Oh. Yes, this should be I, right? Yeah, okay. So then stud list of stud unique footer node from, and then so for each pair of basic block value, I guess, and I get predecessors, yeah. So then we want from, push back, we want to resolve, value, and v. So we can make this underscore even. So this will take stud move to, and then stud move from. Yeah, okay, that seems fair. And then function trees, gonna push back, he stood move that. I'm learning assembly and overwhelmed. Yeah, I mean, there's just a lot of stuff, but once you get used to it, you can kind of like intuit about it a little bit easier as well. There's just like some quirks here and there that make it really annoying. Okay, this should be good to go. Yeah, so that's phi implemented. How many to-dos do we have now? We have 21, the number one up. That's annoying. Yeah, okay. Okay. So what do we need to do right now? I guess we did the final cleanup now, so we can just do this. So we want, I guess we could kill some of these to-dos real quick. We could get some of these done. But I think, barring just like implementing these, I think we're in a pretty steady state. So we can, yeah, we can add the header. And this one, finalize nodes plus visitor helpers. So we finalize node color tree node types and tree gen visitor helpers. Okay, and then here, okay, I guess we could just do some implementing and then we can commit it later. How do we make a label again? Do we have a label? I think we have a label. Yeah, we have a label, okay. So auto label equals to make unique LIR label this takes in, oh boy. We can do F, get name, I think, and that's good. Or not? Huh? Oh. Whoops. There we go. Label needed a visitor or accept. Okay. So then, yeah, so we do that and then, so we can do instructions, push back, label, move it, I guess. Yeah, so we can do that. And then, yeah, I think we could leave the other to do. Yeah, and if we look at how we figured out labels, yeah, so it's just a function. Yeah, so we can leave that there. Here I think we want, maybe we should save the function as well, or the function name. Do that. I can just like type properly. Yeah, okay, so we can do that. We can do that, and that makes that easier. Let's actually throw this up top here. And then we can add a field, which means we still haven't finalized the visitor, because we still need this for like other labels here and there. And then we number the program, right? So yeah, we number the entire program, so we'd have, that makes things a little bit more annoying, but that's fine. We will just hemorrhage some numbers, I guess. It's gonna be some really messy assembly that we generate. Yeah, so here we want, actually we could just do this, right? Do that, and save that. Yeah, and that works. Yeah, I like this. I like the way this is structured. So we make the label, we push it back. Maybe we push back color save registers, I'm not sure yet. Yeah, we can do this. And then, yeah, okay. So we can clear that. Yeah, that seems reasonable. Here we need to generate a label. We can copy this, but we need to be a little bit more creative here. Yeah, because we need function name, and then we had a format that we figured out here. So label, or std string label name equals Vienna dot. We're gonna add function name, and then we want underscore, and we want nr get number of basic block. That's wrong. Std to string of that. And this will take label name. Built-in Sterling is context expert? That's really cool. I did not know that, I can't lie. Okay. So that looks good. This should just go in the function preamble. No, this is the function preamble. So that's done. Where's the green I used for this? This one? That looks about right. So that's done. Yeah, this is good. What else did I finish? Start end function. We haven't done call yet. We did fee, so that one's done. How many to-dos do we have left? The number went back down to 18, nice. So that one, that one. So we have the one in call, we have the one in return, we have branch and con branch. Okay. So just all of the stuff that I really didn't want to do to begin with, which is really funny. Return seems like it's going to be annoying because I need to figure out calling convention again. This one might actually not be bad. We should probably do like next branch or something. Okay, my OBS paused for a second. Apologies. Stream still good? I hope it's still good. I'm gonna assume it's good, and if someone complains, then I will assume it's not good. Looks fine? Okay, cool, perfect. Yeah, we love OBS. What else do I want here? I want next block, I think, or cur block and next block, I guess. Yeah, we can just do like set next even. What's good, John? Serialize the graph? I've kind of done that, I think. I've accidentally done that through my, I guess, toString for my middle end IR. If we look at the tests, just any of these are technically graphs. These are definitely directed, and they could be cyclic. These are digraphs at least, and they are serialized. So, in that sense, I think I've serialized a graph. Hopefully that's a reasonable implementation. So what I need to do is, this should be void. We should do set next, I think. so we can do this. This takes another basic block. Actually, we could just paste this over here. Yeah, okay, we can do that then. How'd you store graph in Redis? Yeah, that's a little bit more annoying. I haven't given that much thought. I mean, what you're caching is probably just like, you'd probably be caching some sort of serialized form if you don't want to like nuke the cache. So I imagine you just stick the serialized form on there, or maybe just like the memory representation. I'm not sure. Team go to now? Hell no. I like my code to be readable. You can do for returns, put the return value in RAX and jump to the exit block. And have only one exit, which is filled in after regalloc. I guess that makes sense, yeah. That seems like a pretty reasonable way to implement it. Yeah, a lot of calling convention stuff just doesn't really make sense without like doing regalloc first, actually. It's like a catch-22. I can't really do regalloc without the instructions, but I can't really I don't think I can really I can't do a lot of the instructions. Yeah, if I need regalloc to do I need the instructions to do regalloc, but I also need regalloc to do the instructions. English is hard. Yeah. When are you gonna stop being on Windows all the time? Eventually, someday. It'll be a while. That is a good use of Go too. Okay, so we only need to set the next block, I think. We also need to set curve block, actually. Yeah, we're gonna make this a little bit more stateful, which is annoying, but it is what it is. Yeah, so we can do curve block and next block. And then those will, do I need to initialize those? Are those just null pointers by default? Indeterminate, okay. Okay, we need to set these as null pointers. Okay, so that we handle. This we don't care about. These two we need to set in the constructor. Yeah, so NR we want to do like that. Per block is null putter. Next block is also a null putter. Yeah, like that. There we go. Null declaration? I guess, yeah, but I kind of don't want to throw it in the header. It just seems a little bit sloppy. Okay. So what was I doing this for again? Oh, right. I want to generate branches. That'd be great to do. Okay, so get successor. So if that is not the same as, actually, do we even need the current block? We kind of only just need the next block. Yeah. Yeah, we can just do that. Yeah. Yeah, there we go. So if that is so if it's not the same as next block, how do you implement the command Z portion of Google Docs? If you're talking about undo, I would do it with a tree. I do it with a tree. Not a list, it's a tree. Okay, so if it's not the next block, then we need to generate a branch statement. So we want auto branch equals, or what's it called? I guess we don't have a branch yet. Why? Because undo history is not linear. Do we have a branch statement? I don't think we have a branch statement yet. We haven't commented out. Okay, all good. Okay. What would you say your understanding compilers is at right now? It exists. I won't say it's incredible, but it's at least something. I have good understanding of the front end, I think, at this point. I have some understanding of the middle end, and my back end, I think after I implement this, I'll have a pretty solid understanding of. I think you usually just lose branches when you start typing again. Yes, but that's kind of annoying. And I would like to have all of it, so I would do a tree. Or at least, I remember Neovim uses a tree at least. For that same reason. So you could get away with just like a stack, I guess, but that seems a little bit annoying. So I'd do a tree. Yeah, so we don't have branches yet. Let's add instruction. How do you get back on a different branch? You could probably just use like a GUI for that. I know that Neovim has like a undo tree navigation plugin, so it'd probably be something similar. Okay, so then how do I do this properly? Guess we could steal some of this code. What is the clean way to do this? Wondering because something for a job and I don't think sales reps are going to use that? I guess that's fair, yeah. In that case, I'd probably use a stack, I think. A stack seems like the most logical choice, at least at a glance. But I imagine there's some like speed concerns. Okay, next block. How do I implement the logic for this actually? This feels like FizzBuzz. This is like actually FizzBuzz, holy shit. Okay. So it's not next block. Oh wait, no, not a stack, a linked list, I guess. Because we'd have to be able to redo. Yeah, I would say like create just like replaces the next node, and then if that's not a no pointer, you'd like dealloc everything. Two stacks is smart, actually. It's like it makes me think like half linked, doubly linked list, which is like a really funny way to think about it, but yeah. Okay, so we want what is the logical states for this? We should have a canonical form, so I think this should actually just simplify things. I think the first condition should be the jump. The second condition should be the fall through in a conditional branch. Just generate the con branch here. I guess, yeah. I also need to generate the comparator, I think, as well. Because I'm gonna have like a traversal order that's linearized, and then I store next block. So yeah, so I guess like let's use black. So we have con branch, next, and then other, I guess. So that's one case, and then the other case will, there's two more cases. There's con branch. There is dot dot dot. This is next here. Right. Let's keep it the same. And then the other one is neither is next. I should add an underscore there. So then this is dot dot dot, and this is also dot dot dot. I could probably just canonicalize it in some way to exclude this case, and that would make it easier. Yeah. Printing a tree in the terminal is in a pretty way surprisingly difficult. Yeah, it really is. If I had to do it, I would just do it in like the nested file structure way. But even that's not ideal, I would say. So this case is easy. Or actually, this case is easy. So this one we can do cond. Okay. Yeah, we can cond branch to the next, and then yeah, that's it for this one. This form we need to invert the condition, I think. We'd have to invert the condition, or we just like don't generate this case to begin with, I think is the simplest way. Or actually, if I'm doing like, I should probably specify this a little bit more. This is the true branch, or this is the false branch, this is the true branch. Those look the same. F. This is an F. This is a T. There we go. This is an F. This is a T. An attempt at a T. This is F, and this is a T. But that doesn't matter here. Okay, so I think so then, yeah, so we can just canonicalize this one out of existence, I guess. So we can just get rid of that one and just never generate that. And then here we could con branch with T, then this goes to next, I guess. And this will be like the jump specific thing. Yeah, so we can do that. And then we can just fall through to dot dot dot. This one, con branch. This kind of breaks down A. I guess we do A and B. T to A, and then branch to B, I guess. BRB. Yeah. You draw nice F's and D's? Thank you. I do a lot of mouse handwriting for some reason. Yeah, I think the easiest way to do this is just canonicalize it so this is not a case. And we just assert the false branch as not next. We can just do this, I think. That's the least awful way to do this. What's your favorite movie? I don't know, actually. I haven't watched a lot of movies recently. Favorite YouTube video though? Probably, currently my favorite YouTube video is the Badger song. It's such a good video. Yeah, I think this is how I will handle this. Yeah, okay. Let's do this. So this doesn't work anymore, so we should false branch should, or we should, false branch should be canonically be never be next block. We can't really do assert here, I guess. T get F successor equals F or next or next one. Okay, so it does exist. God damn it. Prime General Casey, I like Prime. He's my homie. This domain error. I don't know, I haven't watched a lot of Casey, so it's hard for me to give a good good evaluation, I guess. Logic error, I guess? Is this what we call it? Or... Ah, here we are. No, we can domain error, I guess. I think that's the correct one to do here. What's wrong here? Semicolon. Of course it's semicolon. There we go. Let's say you have a graph and you want to detect loops and assign the looping node a number so it can be only be passed a certain number of times. Wait, what? What do you mean? What do you mean by that? Like, we can just like we can hit a node n times tops? Is that what you're saying? I see. Okay. I mean, it's like a visited set, except instead of a set, we just keep like a counter then, right? That seems like it'd be kind of slow, but it might work. Or it's like if we detect a loop, then I guess actually no, that's no different than just like having a visited list. Because if we can hit it once, there's no point in continuing on that loop because we will just keep looping, right? If we've hit a looped node. If there's a loop inside the loop, then well then we unwind from that little loop, and I mean if we're like still detecting, oh, I see what you mean. No, that should still work. Because we'd still like explore the other branch. Yeah, we could just, but also like, is there a reason to continue above 1? I can't think of an instance for that at least. We want to generate the con branch regardless. Oh, wait, I'm doing this wrong. False should be next block. This should be a, let's paint over this. This should be a T, this should be an F. Right? Wait, yeah. Because the fall through should never, or the tree bench should never be next. That would be awful. So this should be an F, this should be a T. Yeah, okay, and then this doesn't change this, I guess. So T, this should be dot dot dot, and then yeah, okay. Do you think there's a case that wouldn't work? I can't think of it off the top of my head. Also, that's good, Anton. Good to see you. Do you know if most compilers borderline buffers? Buffers for string and vector? I feel like they would. It seems like it'd be a little bit silly to not. I feel like. Like if it's being treated like just an array, I imagine that it would be aligned at least. Starts with compiling down to an int compare for a 4-char prefix. Yeah, that's crazy stuff. Yeah, it's all crazy work, I guess. Okay. How do I do this again? What am I doing? So this should be false. False should not be next block. This makes a lot more sense. Wait, this is exactly what I did. I might have just bamboozled myself. Okay, so then halting. Actually, yeah, it's a halting from. Man, algos is so cool. Holy hell. I need to learn more about everything. Okay, I've bamboozled myself here. Regardless, we should generate the conditional branch for the true. Right? Yes, and then if false is not next, then yeah, okay, yeah. Okay, let's replace this real quick. And then for false if, let's give this another line. Let's do false if fall through, or can't fall through to the next. Okay, so we should generate the con branch regardless. I don't have that in my assembly IR yet. Because, well, it's kind of annoying to do, so. Yeah, we'll do that later. Or con jump if true, or for T successor, and then wait. What am I doing? So the true successor is either the... Wait. No, this should be T. Okay. So true successor should never be... Yeah, we should never generate the conditional branch to the next block. I guess whatever lives in the next block. Yeah, so then, yeah, okay, this makes sense then. Because that way we can be lazy. So we can generate that, and then if T get F successor, this is next block. Or is not next block, then I just did WQ, god damn it. Okay, this is how you know it's approaching my bedtime. Okay, so we want, we'll just jump for F successor. Yeah, so we can get rid of these. Yeah, and then we can push it onto there eventually. That looks reasonable enough. I think that means we've added an extra to do. Yes, we have. Okay, well, all good. The rest of the stuff that's left is just like calling convention stuff and then like things I should patch, but I don't want to do that right now because I'm quite tired. So I think this is a pretty reasonable stopping point. Graphs are everything? Yeah, they very much are. Both in terms of like real things and like, I guess, silly toy program things. They're everywhere. Truly, truly everywhere. Gotta look at the Elixir docs. Yeah, I might, yeah. I probably won't. I haven't really had a reason to use Elixir, at least. I think I also need to just understand distributed better. Yeah, there's just a lot of competing priorities, unfortunately. Alright, what did I change here? Like we needed a little more for... How does this live in again? This is visitor. And then this we implement all visitor. What is this called again, the visitor? TreeGen visitor. Functions and helpers, I guess. Format. Man, okay. What did that change? Oh, so now it, okay. CBA. The difference one character makes. Okay. Okay, I think that's a good place to call today's stream. We had a whole 8 commits, which is a really fake metric, but we actually got a decent amount of stuff done across 2.5 hours. Thank you all so much for watching today, especially if you stayed around for all of that. That is a non-negligible amount of time, and I appreciate it a lot. If you haven't already, make sure you like the stream and sub to my channel. It helps out a lot with the algorithm and gets my content out to more people. And of course, you should join the Discord. That's the best place to get pinged when I go live and stay up to date with the community. Stay up to date should be used in the next sentence of my little spiel, whatever. Add me on GitHub, connect with me on LinkedIn. That's the best place to find out what I'm doing. All right, I'm gonna go enjoy the last couple hours of my evening, get some food, and just relax. Take care, y'all. Take it easy, and have a wonderful rest of your day wherever you are.